There we go. Where we have nvars, and these are also just like installed by the user. Now, I'm going to make a couple of constraints onto our problem just to make this easier. I'm going to assume nvars are completely locked and cannot be, I cannot. Nvars are completely locked and cannot be modified by, I cannot do that. Nvars are completely locked and cannot be modified by the end user at any point during the runtime of the system. We'll just simplify this a little bit. We'll assume the things that we are allowed to modify are the files and where you should be able to install new things into our system.
Okay, so like the packages and things like that, like pip packages and things. Okay.
Exactly. Now that we have our environment defined, let's talk about what the user is going to tell us. Oops. The user is likely going to give us some sort of instructions. So like instructions. And this will come in the form of some text for now. We can talk about multimodal later, but just to keep it a little bit easier, we'll talk about just text. And at some point, what I really want coming out of this is effectively a new environment that somehow has slightly different files. Oops, let me make this the wrong thing. And then Excel. Okay. Somehow what I want to do is I want to take some environment and some instructions and spit out a new environment out of this. So at the very high level, what we'll do is figure out how we can go do this. Now, there's a couple of different problems that we want to go into this. The first problem is the user's instructions may not be very good. The second problem is I will somehow want to know exactly which files are actually relevant over here. So I'll start writing some of this stuff down. Why is it so ugly? Okay. Cool. Instructions unclear. It's very hard to write. The instructions are going to be unclear, and then also we're going to have to find the right files. But let's assume that these two problems can eventually be solved. Somehow we can write a different bot that can go solve these problems. Even if I have the instructions and I have all the right files, there's another problem, which is generate the right code. And this last problem ends up, in my eyes, being a lot more complicated and harder than, or at least being perceived to be a lot more complicated and harder than it actually is. So before we dive really deep into how to clarify instructions and how to find the right files, let's focus on the bottom part of the problem, which is how we can actually generate the right code, given clear instructions and the right subset of files involved. Let's see what we can do to take advantage of the fact that this is code and not plain English. So when I go write this, there's a couple of different things we can do, but I'm going to write some pseudocode over here. Def update file instructions stir, and then files map stir. Let's talk about what pseudocode for this kind of problem would end up looking like. The first things we could do is we could just ask the LLM to regenerate the whole file. That is probably not going to be very effective, just because eventually we all have files that are more than 4,000 tokens long or 8,000 tokens long. So we just know off the bat that that won't work for any sophisticated system. So let's break this out into smaller things. What we'll do is we'll have it generate diffs of some kind. Generate diffs, instructions, files. And the reason that I'm jumping straight to diffs and not even talking about why to generate files is, again, because it can't actually be solved. It's not possible, given the output token limits of the models today, to really solve the constraint around this problem. And yes, I know I can run a while loop on the models and let it keep generating more tokens. But at least in my experience, the code bases are a little bit too complex to have it go do that. Diffs seem a little bit more tractable and naturally compressing the information I need to just what I need. Now what I can do is for diff in diff, or maybe I should do this. Apply diffs, files. And somehow I should be able to generate new files by then applying the diffs. And once I apply the diffs, I want to somehow run some validation. validate, validate where I'm going to pass in instructions, new files, oops, files, and then have some sort of result out of this. And what I might want to do is more along the lines of this. While true, solve.pass, return new files. And
okay, so this is kind of breaking down the core of just bag of tools into some kind of more smaller deterministic glue between some really focused small things we can write as really focused small prompts.
Exactly. And the real reason that we want to go do this is because if I go look at what generate diffs can do, this itself could be a whole agentic loop on its own, and we'll go talk about this. How you apply the diffs could or could not be an LLM. And then the actual result itself is likely not going to be an LLM because at some point we want to probably run some code to determine if it's good or bad. So let's go talk about how we could apply the diffs to our system. And then I think the last thing I'm going to go do is let's talk about how we can generate the diffs. So when I go into the diff generation, I think the easiest way to talk about this is actually writing some code. So I have some code over here. Where'd it go? And Dax, you want to give them a quick walkthrough on what this code is that I'm sharing?
Yeah, I think you should pull the latest though. I think there's an extra file in there. There you go. So there's not much here right now. So we've got some kind of like baseline. So we have a project on the left, which is just a small little like calculator application. Is like a CLI that can run basic calculations. I showed it to Vaibhav. He said it sucks. I was like, perfect. Let's get the agent. Let's have the agent make it better. I actually agree. This is a terrible implementation of a calculator. I think Claude wrote this. So yeah, if you want to do math, you have 7 steps to add 5 + 2. So this is the program, the example program that will have our agent code up and make better, and will improve the kind of UX of this thing. But and then in this other folder in agent, we have kind of a scaffolding out of a small AI application. The only thing that's already written here is just code to walk a directory tree and give us kind of a dictionary of file name to file contents.
Yep. So let's start off with the first part. Let's generate a diff. Now you've all probably seen functions that generate diffs before, but I'm going to show like 2 or 3 different options of how to generate diffs because they can make a huge difference. And especially if we have, especially the minute you start going to smaller models, it can really, really dramatically change the quality of your results as we go talk about this. And I think that's going to be a very interesting part about this. So generate diff, what we're going to have is instructions, string, and then what we'll have is like code. And for now, we'll pass in only a single file. We won't pass in more than one file at once. We'll ask it to generate.
So that's like the current code, the current state of the file, basically,
exactly.
right?
I'll call it. Yep. I'll call it something better. Current code. Cool. And what I want to output is some code. I'll use GPT-4o for now, and I'll bump myself down. Instructions. Here's the current code. Set output format. And then what I will do is I will probably do this .role user because we're using OpenAI's models. They send to like system instructions with role users, and then we'll add another part of it, which is going to be file path. No, I don't need file path. Okay, let's just add current code. Okay, let's open this, and then I'm going to start pasting in some test cases really fast. Oops. Okay. And when I go ahead and actually get the calculator, let's grab this calculator code just so I can test it.
Mm-hmm. Sick.
Now I have something I can go test really fast that is doing interesting things with the calculator.
Oh man, this is so clean. What instructions are you gonna give it?
So what I think I'm going to do is I'm going to say, let's say I want to add an exponent capability on it.
Cool.
Operator. So it's a pretty clear instruction. The code is pretty clear and it's pretty self-constrained as to exactly what it should go do. And I probably want to go ahead and figure out what it can go do. And I don't, what does do? I don't even know what this is. And then it's going to go add, multiply, divide. So it will have to touch multiple files in the system, but we'll just see exactly what we can do if we can go add the exponent operation to the calculator. If I go run this, it will probably go do something. And the first part that we'll get is it's not going to really be able to do it in the right way. It's going to offer like a giant update system in a way that isn't very useful. So let's make it actually better at diffs. Class diff. What we'll do is like we'll say goal string.
That's just kind of having it outline its reasoning a little bit before it goes out into generation.
Description. And then I'll have it generate the diff right over here. And I'll say the return type of this is going to be a diff. So now what I have, let me do word wrap. Now what I have over here is I have a method that can go ahead and return some sort of goal and then diff back to me. Oh, I probably don't want to call this goal. I'll call like update description.
Cool.
Cool. So it kind of did a diff, but it did it in a format that is kind of useful, not super useful. Because I can't actually be guaranteed that any of this is going to be abided by because I didn't give it a way to read the diff. So let's add a little bit more constraints onto this.
Wait, I didn't quite follow that. Because I saw that my first impression was like, oh, that's a diff, that's a patch file I can go apply to my project right away. So what's missing from this?
So the first thing that's really missing from this for me is a couple of things.
Yeah.
And the first one is really just the fact that like calculator original.py is probably not the name of my file. Right?
I see. Okay.
Calculator updated.py is not the name of the output file. There's the small nuances, and I think these nuances are dramatically going to change how we parse it and go read things around it. But
Okay.
what I do see is
You
that this thing probably wants to know what it is going to go do. So let's give it like a file name in general.
okay. Real quick, by the way, there was a question about like which part of this is in the user message versus system prompt. If you want to
So what
clarify
I am
that.
doing right now is everything above this for GPT-4o is generally going to by default be in the system message, the instructions that the user gives me and the output format I want, and the actual code goes into the user message. I'm basically treating the instructions of the user as good as instructions that I gave on the team, as someone on our code wrote. Even though it's user incoming message, I treat it like a system message. So let's talk
Because
about a
it's like,
couple
what
more.
is it? Like a lot of the models have better instruction following for what you put in the system prompt, right?
Why not put the current code in the user prompt? Um, oh, why put the current code? So there's a couple of different reasons of why we put this in the current code as opposed to the user prompt. And the biggest reason is just like the way the models are oriented. So let's just take a look at what this does. If I were to go read the prompt, you can view like you can view these role semantics as basically just like automatic oops, I should fix that. As automatic breakers for where the code actually lives. So now if I were to go write this, it isn't actually obvious where the section of my code begins or doesn't begin. I'd have to add some prefix like code here. But if I'm using
I
user
see.
system messages,
So
I kind of get that by default because these are special tokens that the model ingests that let it know that it's delimiting something by default.
okay, so you're not really relying on the assistant user tuning in terms of like a chat conversation, but you're just using switching to user mode as a really, really well-tuned separator between whatever came
You
before and
nailed
whatever's
it.
coming next.
Exactly.
Cool.
Because the model is well tuned to understand this, and this gives me a really, really free way to go paste this down.
Yeah,
Um,
I think he's saying like basically like if you used XML tags around it, that would be similar. We're just using this for the purpose of separating.
yeah, and like we can go do this, and like this we can do this even now, but we really don't need to because this is pretty well understood in terms of what the errors they could have are.
Cool.
Okay,
Sorry, you were talking about diffs.
let's go back to diffs. Now, I do like the update descriptions. I think these descriptions could be a little bit better. So like let's just rename this to update notes. And right now I'm just updating it directly rather than changing like alias or anything because I'm not really using this code anywhere. And now let's talk about diffs. Now okay, so return in this format. Let's give it a more constrained format. Diff. And then what I want is I'm going to make it generate the diff in a markdown blob. And I'm going to try and look like this diff as much as possible because this seems to be the thing the model likes to do. Is this like proper? My file.
Yeah, Gabe, great question. Yeah, so we're going to start with GPT-4o, and then
Work our
we're
way
going to
down.
show how we can use some prompt techniques to make this work really well, even with 4o mini or something.
There we go. So I'm going to let it go do this in this example, where the way that it's going to generate the diff is I want it to tell me what file it's removing, what file it's adding, and then it's going to put in some like line numbers or something around this, I guess. And then surrounding code, add the deleted code, add the added code, and then give me back surrounding code at the very end. And it added the closing XML marks by default, so it didn't really work. So I updated so it's not a closing tag. Now this clearly looks like it could be misinterpreted, so I'm gonna write it like this, just to like make it a little bit more clear that's not XML or something by default. So let's try running this now. Return this format. Don't need quotes to escape this. What is it doing? So let's go read this code and see what actually pulled out. So it did actually do something pretty nice for me, whereas it gave me a diff. It said these lines change. And then it gave me another diff where it says these lines changed. And it told me exactly what I need to remove and add out of this format, which is kind of interesting because it actually was able to detect that the divide needed a comma and then it added the exponent.
Mm-hmm.
So this
Cool.
seems to work pretty well in terms of what it's parsing and what it's returning back to me.
Looks like it did still have the backticks though. Were you trying to get rid of those?
Yeah, let me see. Return this format, use. So I told it not to do something. As we saw, like my prompt said, don't need to add quotes to escape this. So instead of a don't, let's add this. Let's give it a capability instead of removing a capability.
Yeah.
Use triple backticks to
Do you want triple backticks though?
to
Like, aren't you
prevent
just gonna have to strip those out later?
characters. So I'll show you what I mean.
Okay.
Um, let's see if I can get it to do this. Uh, let's call this field something else. Oops, sorry. And this is kind of like a version of few shot sampling, I guess you could say. That's trying to produce some good code here. So let's try and run. That's funny. We have syntax highlighting. It's broken. Did you go do it? Nope. It's still adding the triple backtick. So it sounds like I can go do this.
So you're
let me
telling
tell you
it to
why
use
I'm
triple
trying to use triple
backticks.
backticks. Let me tell you why I'm trying to use triple backticks. So the problem
Okay.
is if I don't use triple backticks, it's going to put the thing in quotes. If I put it in quotes, it's going to be really hard for me to find out where this quotes start and stop because my code itself has quotation marks in it. So when I generate the diff, it's going to break eventually because if it doesn't
Okay.
escape the quotes correctly or do something else correctly, it's definitely going to go break. So maybe what I need to do is I need to call this diff update diff code. Let's call this updated code and then try something here again. Use triple backticks to prevent escape characters. There we go. So what it looked like is naming it diff over here was confusing the model. But now that I'm using a name that's a little bit more unique and specifically not related to the actual thing, because I'm overloading the word diff to mean too many things. It's both the name of my output and the action that I want it to go do. So by renaming it to update code, it's probably just a little bit easier for the model to go understand what's going on. Escape characters, no quotes. Let's try this one more time. See if I can get something good. Nope, the other way was necessary. Okay, cool. Oops, there we go.
Okay, so this is actually a sort of like an intuition you have about specifically about how the BAML parser is pulling things out of this field.
Well, it's also just about what I need the model to go do. I do not want the model to worry about these quotes because it will mess up because I'm generating large sequences of code.
Oh, because it's trying to make JSON and those triple quotes are gonna like make it think that it accidentally made invalid JSON or something.
Exactly.
Gotcha.
And that's going to be a really, really hard thing for me to go get. And the raw output of the prompt looks like this. I think someone asked.
Yeah, so that context, that output format ends up translating into this. This is like the full raw prompt.
And I'm noticing like answering JSON the schema. I'll just get rid of that really fast because this is so finicky. Prefix equals answer using the schema. And the escape character is like. And then why is it outputting in JSON? So let me go update this.
Okay, so your concern is that it's trying to escape all the quotes in the JSON, and the concern is that if the model has to think about that, then it's going to kind of gum up and take attention away from the core task, which is generating good code.
Exactly. So let's add a couple more things. Okay. Let's add temperature 0 to my system. Let's run this one more time and see what it does. And let's try this one more time. What I'm going to do is I'm going to actually move this out of the description and just try seeing if I can give it a few shot example right over here. Allow for no escape characters. And now the prompt looks like this.
I see. So you took the description out of the actual schema and you're just adding this as a standalone instruction.
Exactly. To allow for, oh, I know what, to allow for multi-line strings. There we go. And now we have it working.
I see. Okay, so and this comes after the thing I think I've heard you say a lot before, which is this idea of like, let the model write code in the way that it's most trained to write code, which is not code inside a big JSON object, but is just stream the code out flat as an actual file. And so by telling it to use triple backticks, the model thinks, oh, now I don't have to deal with escape characters. I can just do this as multi-line string.
Exactly. Exactly. And one quick thing to note here is I told it to a multi-line string, and you saw me iterate on many different ways. I wrote a lot of knots in the before. And really what I was able to nail down here is by getting rid of all the knots and really thinking hard about what I was trying to get it to do, which was really just like I wanted to output multi-line strings. By letting it go do that, it can now understand exactly what it's trying to go do a lot better.
Right, because it hasn't been trained on generating code inside a JSON object. It's been trained on generating code as a flat thing.
Exactly. And like it's really about the knot concept that is hard to go wrap my head around, especially the minute I go to like a smaller model. So let's use like a smaller model like this one. Temperature 0.1. Let's just boil this down and see if it does approximate the right thing. The idea of a knot is just very, very hard for it to go do. And now you can notice that the diff has gone a little bit longer because it's a slightly smaller model. And if I'm doing this, the first worry that I have is, oh, is the model just outputting like a lot more code than it needs to? Let's see if I can trim that down. One easy way to trim that down is to just make it return multiple diffs instead of one diff,
Cool.
right? So let's just go do that. Let's let it return another diff. Let's see what it does. Oh, it's outputting a lot more code. Let's add some instructions. Keep diffs small and can use multiple diffs. I wonder if this thing is messing it up right now because it's actually telling me that technically the diff format allows for multiple things to be included. So let's get rid of this.
Are you going to be able to plot? Keep going. I have questions, but let's see
for
this
the
example.
same file. Okay, let's run this. Just see what this does. This did not add any pluses or minuses, and we'll talk about this in a little bit later. And let's go add one more thing. Let's actually change this to be update notes, just be a string instead of a multi-line string. Because what's likely happening is writing multiple diffs, and then it's going to head and just not really understanding what it needs to go do. So what we should really do is class updated code string array. So here's what I'm going to do. I'm going to let notes be multiple. And for each one of his notes, I want it to generate one code sample. And I'll add this in here. Use proper multi-line string. I think this will work. And then this will return multiple, and then I do not need this anymore. And one more try.
What's the prompt look like now?
There we go. So here's what the prompt looks like now. Let's go read this fast. So what we really want to go do is we want to say that we're going to generate a triple backtick string for multi-line files. We're going to literally let it generate the code. Then we're going to say you can actually generate multiple diffs in this format. And then we're going to keep the diff small, use multiple diffs for the same file. What the model ends up generating is something actually very useful, which is add exponentiation operation to the calculator. And this is GPT-4o mini. And actually, it was able to break it down, say my file, it says I need to go add exponentiate over here, and I need to go ahead and add exponentiate down here. Now, the thing that's missing, it looks like, is the at symbols actually helped it quite a lot. It also added an exponentiate function directly into this method instead of adding it to the import. Let's go ahead and add a little bit more context onto here.
Do you want to tell it what file name we're changing as one of the parameters?
That's kind of what I was thinking as well, because it seems like it's getting confused by this. File name, file. And that's probably good enough. So now let's add file name calculator.py. So let's read the prompt one more time. We have file calculator.py. We have the actual contents of the file. And then what we really have is, let's run this code one more time.
I just want to let you know we're at about 20 minutes left, so I'm not sure if when you want to switch to actually like applying these diffs.
Cool. That's a good point.
Kind of the other stages of the pipeline.
Let's talk about the next stage of the pipeline. So we have something that seems to be able to generate some amount of code from here. And we also have something that can also apply diffs. So now let's talk about the next part, which is actually generating diffs. I think we had one last question, which is how much does indentation matter in the description and the prompt? Indentation pretty much just matters because it's just like noise. For example, if I were to not indent this versus indent this, it probably just reads slightly differently.
You want to show the token view? Can we see if it changes the actual like tokens?
I mean, indentation is just white space, but like in the end, it doesn't really matter too much. And the reason it doesn't matter too much is the way I look at this is like, think about like a human reading it for clarity. If I indent this, then the real benefit that I get as a human is I can really quickly jump down here and I see this is where it ends.
Mm-hmm.
The model can also pick up on patterns while reading this sort of thing. And it should be able to detect that this thing, it just belongs to the thing above it because it's indented. So in reality, I should probably be like tabbing these in as well, just because it's just like easier for it to see like, oh, this is like one indentation and this is two indentations. Because there are tokens that exist for like four space tokens. So it's just like it reads two tokens as, oh, it probably belongs to a diff inside of this array. It probably belongs to a diff inside of this array. And I'm going to go back to 2.0. And now I want to talk about the next part, which I think a lot of people overlook, which is how can I actually go ahead and apply this diff? Because once you start applying the diff, the hardest thing that most people run into is actually going to be, I'm going to go back to here, which is when we go ahead and apply this diff and we have a bunch of diffs, most people are like, I'll just go and like string replace, go do this. But actually, the best way to think about this problem is on a per file basis. So instead of viewing this as a massive, I'm going to apply all the diffs at once, what I'm going to do is I'm going to apply a single diff at one point at a time. So this is going to be a diff object. And this will be only that one file that it really touches. And I want to go think about this problem. The first thing you have to do in this problem is you have to go ahead and say, find match diff.old. And this is going to be like some find match function off the old method of the file and then like the current version of the file. And if you fail to find a match, there's a couple of things you can go do. You can toss it to another LLM to go ahead and see if you can find the match. You can use something like Levinstein's distance or something else, see if there's something approximately close to the match. But in reality, if you fail to find a complete match, then this whole thing that it generated at the top is probably not very useful, even if you can't toss it to if another LLM is unable to find another match for you.
Yeah, I've seen Claude Code mess this up a lot, and I think theirs is not like plus minus diffing, and it's a little bit more like string to replace. So they do it with like a find replace basically, and then if it can't find the string to replace, it'll fall back to trying to use like sed and grep.
Yeah. So if you remember, there was this thing that we talked about a couple sessions ago, which is about managing the context in like the case of like an error system, where like when I'm generating like a Cypher query, I'm gonna have the user generate some context, and at some point the model will get it wrong. So then what I will end up doing is when the model gets it wrong, I will add some new context on top of it. I will let the model go generate a new response, and then it will probably hopefully get it right at this point. And for my final context window, what I end up doing is I say, I will literally just ignore everything that the model did in the middle and only give the right query. Oops, I'll change the colors on here so it's a little bit more clear. And only give it the right query and delete these other two contexts out of it. So I'm basically just managing the context and pretending like I got the answer on the first try. I can go do the same thing with the diff system, which is once I find a match in here, whether it's by using an LLM, whether it's by using like a string match, Levinstein's distance, or anything else onto here, I'll do my best to find a match. If I fail to find a match, I have to abort out of the loop and leave and go back. But once I find a match, then I can do a couple of different things, which is I can apply the match. And this is a basic operation to just do like a string replace. And once I'm able to go ahead and apply the match, I can do the next part of the system, which I think is the part that most people never do, which is leverage the AST. What does that mean? Well, there's two parts of code that needs to be correct when I go generate this. One of the parts of code that needs to be correct when I go generate this is going to be that the syntax of the code is actually correct. I can use the AST library Python provides to go validate the file itself. And it's not actually going to make sure that all my imports are correct or anything else. But what it can do is just validate the actual syntax that the LLM generated in the new diff is correct. So For example, if I missed a comma or something else, and I can find exactly what line has the AST mistake, and I can put this in a while loop.
Okay, so this isn't going to catch issues with like imports that are broken or methods from other files that are called wrong, but at least we'll
No.
know that the code was syntactically correct.
Exactly, because I want to scope down the problem as much as possible. Because if I'm going to go use, something like code generation, I don't want to have the model worry about everything always all at once. If I
Yeah.
can have what guarantee do I provide at the first sentence? I provide a guarantee that the match of the old diff exists in some shape or form, matching the existing file somehow. And it doesn't matter that I use an LLM or string replace inside of this method to go find that exact line. All that matters is that I was able to find it. When I apply the match, this is a string replace. I don't have to think about it. But what I want to go do here is I want to make sure that
Okay, so you have another LM with a very specific prompt that is like, hey, here was the change you tried to make, here was the original goal, here were the errors.
exactly. And this is
Generate a
a
new diff,
syntax error, so
basically.
I may not even need to give it. I may not even need to give it. I may not even need to give it the what's it called, the original file, since it's just a purely syntactical error approach. What's
Okay,
nice
and then
about
you
this
would like
method, go ahead.
validate it again or something.
What's nice about this method is that this fix error method, I'm gonna try drawing a curvy arrow. This fix error method could really be a thing. Ooh, I tried. Could really be a thing that goes back to my update files with just a single file with a very specific instruction that I have hard coded to help it analyze the errors. So it could technically go back into my REPL loop and that I'm building out here and have it go generate this. And it could be like a version of this method that doesn't actually need to go run in terms of run the code. It just needs to go make it syntactically valid.
So rather than the errors, you would actually have kind of like some kind of new instructions here. And you're
Exactly.
kind of you're recursing. And then what's the exit condition of this while loop? Is it like, if not errors break?
Yeah, exactly. Cool. That's exactly it.
Cool.
And I can do something a little bit more sophisticated where like if I have like 50 errors or like 20, if like I've done this loop like 5 times, I break anyway.
Yeah.
But this kind of gets me there kind of most of the way there. And this is the same thing. I generate a diff, I go apply the diff, and I run this in a loop. It's pretty similar, but it's breaking down the problem in a way where the only goal of the update file when it enters from the fix errors context is to just fix these errors. If that makes sense. Cool.
Following. Yeah, this is starting to feel like an ambitious topic to try to cover in an hour, but I think this is super
Well,
interesting.
the next thing that we really want to go do is actually find all the imports. And again, we can leverage the AST to go do this. So we don't actually have to use an LLM to go do this. I mean, we could, but we can also just use the AST in the Python library to tell us what are all the imports that are imported into this file. And
Yeah.
any new imports that are gotten, we can just import them. It turns out that this is a pretty straightforward task as long as you have all imports provided to you. So if you see any files that are local files, we can know the difference between those because we can detect which are local files because we have access to all the source code. And we can just update the environment to import everything relative to here. If we run into any errors, we do the same thing over here. Now this one gets a little bit more sophisticated in terms of how you would have to deal with these kinds of errors. And the reason for that is there's a couple of different types of errors that we can imagine that the system has. One of the types of errors that the system could end up having is the fact that stuff just doesn't exist. It's a made up repository. In that case, there's no amount of install steps that we could go do to go fix this, and we'd have to go back up to here and abort out of the system and somehow add some new observations into here that says do not use this library. The next type of error that we could really have is the fact that we just installed something incorrectly in a slightly different way. Like, for example, one common mistake I make is I do pip install .env, where you have to do pip install python -.env. And fixing that sort of error may require some other, like, there's a couple of different ways to go inspect into that. One of them is you use like a web search agent to go and call it and say, how could I fix this error? One is you go ahead and just like ask the LLM how to go fix the error. And there's different approaches here, but in general, you can do this.
Jonathan says, why not both?
Why not both? You can do both. It's just a matter of time and expediency that you really have to think about when you build these systems. Fix errors. Fix install errors. Then I'll call this like fix AST errors. Errors, and then we're going to give it actually the file. And we're going to do a new thing in here that we probably have to think about that I forgot to include in here, which is you want to have some sort of observations object that you're kind of tracking over time that you're going to pass into this system. The observations object needs to be a thing that is passed into every other object downstream that you can somehow modify in some way and then go ahead and update as well. So in this case, you might need to go ahead and update the observations. Unfixable. If unfixables. There we go. And then you kind of just want to abort out of this. Raise some exception. And then on this method, try catch. I can't write pseudocode very fast. And I want to abort out of this loop and really just add some unfixable errors down here. So I think the whole point of what I really wanted to cover today is that when you're trying to go build like a diffing agent, the way most people apply this agent is a very simple loop of ask the LM to go fix something. If it breaks, give it the error and go build that loop forever. And when you're trying to go do that system, the problem with that is you run into a lot of brittle edge cases that the model just cannot fix. And specifically what you're running into is the same problem that we usually talk about, which is context management, which is if you're not manually building the context up out of the system, it is very, very hard for you to navigate and get the model to go output it correctly. For example, maybe GPT-5 or 4.1 can go do this in one shot for a lot of problems. But GPT-4o mini cannot go do this very well. It will just struggle to apply a diff. And it will struggle
because it's
the perfect
its
diff.
ability to actually just like understand full context window, especially as that context window gets longer with more and different kinds of errors. Yeah, you kind of lose the thread and you spin out, right?
Exactly. So the whole point when we talked about like the ciphertext generation, where we're actually able to remove these two messages out of the context window and not have to have them long term, and we only keep them around temporarily, becomes even more important when you're doing a complex task like code generation. And the most important part to do is be able to decompose the problem to very small problems and then say, all I have to do is find a match. Cool. I will take the diff. If I can find an exact string match, I'll go do it. If I can't, I'll use an LLM to find the line of code that's referring to. And if none of that works, then I'll literally just abort and add an observation to my system and then have it go do this. And at some point when it gets to a good state, I want to go ahead and clear the observations.
Right. Because they're no longer interesting to the like next set of problems that we're solving or the next step in our plan.
Exactly.
Cool.
And it's kind of me tracking this history over time And then what I really want to do is I want to go leverage existing tools that are really good for doing certain kinds of tasks. Like the LLM should not be doing syntax validation. I likely also shouldn't be using an LLM to look at the whole file and tell me, here's all the errors, go find out what they are and go fix them. If I instead use an AST to tell me this, then I can give it the exact pinpoint of surrounding code and say, go fix this syntax.
Yeah, I think
Similarly,
Jonathan, that's exactly right. It's like the LLM's job is to turn context into new tokens, new code. Your job of everything else is to get exactly the right, most optimal context into the LLM so it can do that as well as possible, as cheaply as possible.
exactly. And then same with installs. Instead of running the code and telling me what I need to install, I can just find all the imports. So like for example, there's a Python library in here that you can use. It's called like import AST. Def define imports code. You can literally just call ast.parse. And you can literally just walk through this tree and find everything that's in module of AST import. And it will literally just tell you exactly what this node is. And it will actually yield out all the imports for you. You can get import from as well. And I believe this will do everything for you. Now, this won't catch every import because it will miss out on some of the most like edge casey imports that you have, but you can still detect most of them from here. Now the other thing, and I can run this code if people are curious. The other thing that you're able to go do is I could also go generate this. I can also go generate this from actual code as well. Function find imports. And let's just go write this test. Oops. If I give it the same code that I have down below, so if I
You
give it
just
the
have the
same code,
LLM parse out all the imports and
literally I
like,
can just have an LLM parse out all the imports. Oops. And it will probably respond fine. And it says the only import is operations, which if I look at the code is actually true. Right? If I add a couple more, it will pull it out. And the beauty of this thing is there's like this art to kind of figuring out what kind of model you want to go use for these kinds of things. If I were someone, what I would want to do is I'd want to figure out the smallest model that I can use for each task. And in this case, finding imports is a pretty small task. So I could probably throw GPT-4 Mini at it. I could probably throw like a DeepSeek or even like, I don't know,
Haiku or something.
like maybe even like a Llama 8B. Oh, that's pretty good. I figured it out. I think I have Llama latest. I think I have Ollama running. I do not. I can
I don't
start
know if you need the latest tag, do you?
Ollama PS. OLS. Ollama LS. Do I have any of these? Yeah, you kind of do need the latest tag. It's kind of
You
annoying.
don't? Okay.
One latest. B1. I'll figure out why. I'm probably missing some delete parameter here. Well, I'm going to go do this. But really determining what model you have to go use can make a huge difference. So in this case, what I really want is if all I want to do is find imports and I don't want to write the AST code over here, I can literally just use Ollama to go leverage it instead because I know this is a small enough task. And if 90% of my system that I'm writing over here ends up using mostly a small model, but then some of it ends up using like let's say GPT-4o, I can get a lot of value just by reducing the amount of cost that I have to go do in terms of latency and in terms of accuracy. Because the most important parts are I want to do the hard parts as much as possible with a big model. I want to do this. I want to do the small parts with smaller models. And because when I'm going to go run this, I run into this problem where like generate diffs, especially if I'm on day 0 of my system, I do not want to go ahead and like get all of this down in terms of the cost and accuracy. I just want the accuracy to be high and I don't care about cost. I'll throw this at GPT-4o. And because I've spent more time on applied diffs, more of this will be smaller models. And what you do is you incrementally replace parts of your pipeline with smaller and smaller models. And as you add smaller models, the real workaround to make smaller models better is one, some of the prompt engineering stuff that you end up doing. But the real thing is really about like adding supporting systems around them. So you can actually go ahead and make them better. So in this case, leveraging the AST allows me to use a smaller model because the goal of the smaller model is no longer generate perfect code and fix all of your errors. The goal is generate something that's pretty close to correct and be able to fix syntactical errors.
Yep.
It doesn't have to fix logical errors. It only has to fix syntactical errors. And then when I go to validate, I live in this world where I'm, again, validating large running code. And I might have even something detect what kind of error this is. If it's a simple error, I'll toss it at a smaller model. If it's a more complex error, I'll toss it at GPT-4o or 4.1.
And so you're just constantly adding new probes and knobs and dials on your pipeline that you can make changes and you can swap out a bigger, slightly bigger model, slightly smaller model, et cetera.
Exactly. And in the end, all of this is really about a distribution play, right? We have a oops, how do I draw a line?
Up here, yeah.
Draw a line. Okay. All I really want is I want a distribution where the majority of my users fall under this, and I have some long tail of this, and where this is like dollars going up higher. I want to make sure that most of my users fall under this domain. If like 5% of my users are extremely expensive, that doesn't really matter for most use cases. If 5% is really slow, it doesn't really matter. It is going to be really, really hard for someone to build an AI pipeline that looks like this while having good accuracy. That's just not the way AI pipelines can work because of the nature of problems that users will constantly ask you to go do.
Yeah.
So one way to deal with this, especially when your problem is very, very expansive, like generating code, is you design your pipeline from the very beginning to kind of follow this sort of distribution. And the whole point is your pipeline, oh, how do I make this thinner? I hate this. Okay. Your pipeline starts off at a distribution that looks like this. It's very expensive.
Right, you're using big model. This is like what you keep the kind of the recurring point is like start with a big model that can do a bunch of things pretty well, and then
Exactly.
slowly over time, like as you say, oh, this is worth building, this is valuable, we want to invest more engineering time on this. You're constantly shifting that code, that curve to the left and making it kind of thinner and
Exactly.
thinner to the left.
So like what I can do by swapping just the applied diff section, because applied diffs is almost definitely the most expensive part of my pipeline, because that's where it's going to make mistakes. I have to recorrect them and I have to loop in that forever. It's probably not a generating diff. It's probably an applied diff. By shifting applied diff to be better, I probably just shift my pipeline as a whole very much to the left. And then eventually what I can do is I can work on generating things that are really, really good for Python and maybe even fine tune a tiny model for that and slowly just over time shift my pipeline over. But this is the whole point of where you move your pipeline over is all about moving it to the left and adding engineering over here. What we're really doing is we're applying engineering to make it cheaper, faster, more accurate by taking a better control of the system. Does that describe the high level thing of what we were trying to do in today's conversation? It was pretty ambitious, I guess, to take all of this and go implement all of this from scratch.
Yeah, there's a lot of requests for people want to get working code for all of this. So maybe we'll have a hack day this weekend.
Okay,
And,
yeah, we'll go do that. We'll
actually
get a
build
hack
this
day and we'll
out.
give you like working code from this sample and get this out.
No, this is good. And I think what's also like what wasn't explicitly mentioned, but is really, really important to keep in mind is like every single one of these techniques that is like, oh, cool, we'll take a big model and then we'll make it cheaper, smaller, faster, better. You could take all of those techniques and just drop in a big model again. And suddenly, because you're doing these accuracy techniques, your big model is going to perform a lot better than just a naively single shot, single prompted big model.
Yeah, exactly. Exactly. I think what we should really do, Dex, is we should take this code and actually just turn this into real code because I don't think I could have pseudocoded and written the code in real time.
Yeah. Are we gonna
Um,
build an Aider clone this weekend? I'm doing a hack day on Friday, dude.
let's
Maybe
do it.
we'll have you join remote.
Yeah, we'll go do that. So we'll probably send out an email slightly later with today's session with the working code. Expect it probably around the weekend. Are there questions that people have? I know there were a couple that were asked as we were going on.
Yeah, feel free to come off mute and shout and tell us what you liked or what was confusing still, or drop it in the chat.
Hey, Vaibhav. Hey, Dex. Thanks for the great session. So this was super great for the problem of, making targeted changes in code. I'm curious if you guys have any thoughts of, how the problem kind of changes when we're thinking of, building something from scratch, right? So like if I were to go to, StackBlitz or V0, whatever, I want to get a whole bunch right off the initial prompt. How do you guys think about that problem?
I view that as a totally separate problem as
Okay.
updating existing code. So if I were building a system that were going to go do this, and again, it's all about like this left to right movement.
Yep.
The way I'd move this system from left to right, the way I'd move the system from left to right is I'd first build a system that is able to like I'd build two separate systems, like generate new code and update existing code, and really just build a router between them that decides which one I'm going to. And I treat them as two totally separate systems. And that's why V0 is so freaking good at giving you a UI out of the box, but it's so bad at updating code eventually. Because at least what I run into is like I get amazing draft one, chat message one, beautiful, chat message two, amazing. Chat message like 25, I'm like, oh my God, I'm ripping my hair out trying to get it to the thing I wanted to go do. Because it's just not as precise. And it's just this balance that you end up having to go do for now, given today's models. Does that answer your question, Philip?
Yeah, I guess I'm curious how feasible you think it is for something like V0, maybe like what the time, and this is a very loaded question, like what the time frame might be where something like that could be commoditized.
Well, I think a lot of getting this working is actually not about getting it working, but also giving people really good tools. So V0 has started to go do this, but one of the things that you'll notice like Cursor do, so like I'm in my Rust code base, is Cursor will actually let me like refer to actual code right in here.
Yep.
And the reason they do that is because it turns out this problem that I was talking about at the very beginning of finding the right context is really, really, really hard. I get a lot of value by the user just telling me what they want me to pass in. So instead of having to build this out directly from scratch, V0 likely has to build some sort of tooling to make this better. So I'll show you some of the tooling that they've built out that I think is headed in this direction and shows this point very directly. So like, I'll just open this floating bubbles, whatever. Right. And look at what they can do here. They actually allow you to now select these elements very directly and apply quick changes. Why are they doing that?
Sick.
Because if you don't do this, you will not generate good code. Like they cannot do it. So a lot of these paradigms in terms of generating perfect responses not just require like code changes foundationally at the very bottom layer, but they also require UX workflows that are tuned perfectly to the exact way that you are currently writing that code. V0's case means point to that part of the element. Cursor's case means refer to that file. So if you are building a competitor, then what I would do is I would figure out what is the most UX friendly way for the person to give you the right context. Because if you have the right context and you have good instructions, it is really easy to go do that. Good instructions are a lot easier to correct using a model and ask clarifying questions. Bad context is virtually impossible to correct. So just help the user give you the right piece of code. Does that answer the question?
That's awesome. I didn't know that was in V0. I have used V0 from time to time. I do think Browser Tools has that as well. I have used that functionality with the Browser Tools MCP via Cursor. So if anyone's using Cursor, they may want to check that out too. But thanks.
Yeah.
I don't know if there's a hand raising. I just wanted to say thank you. I love the V0. I'm using it more. I do a planning and task operation first, and I tell V0 to write in a documents folder. It will create documents, scripts, everything else. I'll do up to 20 planning and documentation steps before it actually starts to instantiate and write code. What I actually give it is a full PRD with a front end spec that I write outside. I've been able to generate up to like 200 files, half of which are docs and half of which are code, with like 11 different directories with only just a few errors in the final initial page generation, just as an FYI, with the right planning and having it write to its system and read it in a loop.
Yeah, from what I've seen, I'm pretty sure V0 is doing something special with imports and stuff because they see with import detection, like just from relative files, because that's like the easiest way to go fix this. And like, given how technical the Next.js team is in TypeScript specifically, they have a really easy way to showcase some of these errors and go fix these bugs.
I just want to say thanks. This is my second session with you all. I'm new to BAML and absolutely brilliant work. I'm following everything I can. Thanks so much for today.
Thanks, Derek.
Awesome. Love it. Thanks for bringing your energy.
Yeah. Other questions from anyone else that's left on? Cool. In that case, we'll call it a good day today. And then Dex and I will send out working code for this on the calculator repo.
Okay, you committed it. That's on recording.
I mean, yeah, it's recorded. It's gonna happen. It's never hurts to write fun
I'm
code.
excited.
It'll be really fun. All right. Thank you, everyone. And thank you again, Dex. This was really fun.
Yeah, it was a blast. Thanks, everybody.
See you guys
All right,
next week.
thanks.
Catch y'all later.
Thanks, Vaibhav. Thanks, Dexter.
See ya.
See ya.